Okay, so a little video here on our binomial. So the first thing I think to start off with is if you look at your log tables for a moment there, and I want you to look at two different pages. This is page 20 and this is page 33. So pause the video and open your log table on page 20. And also, please open it on page 33. Now, why am I saying this? Well, this is your binomial theorem, and this is your binomial distribution. So the binomial theorem is basically when we're doing the algebra questions. The binomial distribution is when we're doing the probability questions. And I suppose the most confusing thing is, and I'll go through some examples of both of these now, but a good place to start in terms of comparing and why it is, I suppose, something that could be confusing is if you look at how to do this. So when we're going to do these questions in algebra, I normally draw people's attention just to that part because this kind of summarizes what we're going to be doing in algebra. You do n choose or, and then it is x, which is your first term, n take or. Now, the reason I'm pointing that out, so it's n take or, is because when you compare that to the binomial distribution, you still have the n choose or, but when you go to do the first part, notice this is n take or, this is or. This down here is just or. And then in terms of the second part, sorry, this is a bit glitchy for some reason. And then when you're looking at the second part, it's the opposite way around. So notice that this is to the power of or. And when we look at it down here, this one is to the power of or. So can you see that they are switched? Now that could be incredibly confusing if you didn't realize that or you didn't remember that. So be very, very careful. Now I'm going to go through some examples of both just to make it clear, but you really need to be confident as to which page you're using because the order is different. The other thing to point out is with binomial distribution, we use these for what we call the Bernoulli N-O-U-L-L-I, I think it's spelled Bernoulli trials. What I mean by that is it's just a fancy name for what we call the success and failure questions. And again, I'll do examples of those to explain that a little bit better. Okay, so let's go to our first question here. Expand and simplify. So this is a binomial theorem question. There's nothing to do with what are your chances or, how likely. It's nothing like that. It's a straightforward algebra question. So I'm going to page 20. And on page 20, I see the binomial theorem. And I basically look to this formula here. Now, how do I use this formula? Well, it's very simple. The binomial theorem is just a brilliant way to multiply out brackets with high powers. I mean, if it was power of 2, you could just write it out twice and multiply it out. Easy. But if it's power of 4, power of 8, power of 10, you don't want to be writing out the bracket 4 times or 10 times. So this is what the binomial theorem helps us to do. So what we do is whatever the power is, you begin and you say 4 choose, and it's always 0 first. You then count your way up until you get a match. So 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Now I know to stop there. Why? Because it's 4 choose 4. I have a match. I can't do 4 choose 5. That's just not possible. I mean, if I have 4 people, I can't choose 5 people from 4 people because I only have 4. Also, you might remember when I was teaching you this, I was saying that whatever the power is, you have an extra term on that. So in other words, if the power is 4, you have 5 terms. If the power was 11, you'd have 12 terms. And it's because you have the 0 at the start. You then write each part 2x, 2x. So every term gets a 2x. and then every term gets a -2. So you're basically just taking that bit and that bit. So that's usually how I start off my binomial. There's going to be a plus in between. Now, it's obviously really important that we get these powers right. So the formula says it's the top take the bottom. So it's going to be 4 take 0 is 4. And then here we just have the bottom, which is 0. So we copy that all the ways along. 4 take 1 is 3, bottom is 1. 4 take 2 is 2, bottom is 2. 4 take 3 is 1, bottom is 3. 4 take 4 is 0, bottom is 4. So that's it. So then we reach for our calculator, and hopefully this is the easy part. Now, if I have 4 choose 0, that just gives me 1, because it's like if I have 4 people in front of me, how many ways can I choose nobody? Well, there's one way to do that. You don't choose anyone. The next one, we have 2x to the power of 4. So I'm going to raise 2 to the power of 4, which is 16. And I'm also going to raise x to the 4, which is power of 4. Anything to the power of 0 is 1. So just take your time here. Use your calculator. Take your time. 4 choose 1 is 4. 2 to the power of 3. So we're doing 2 by 2 is 4 by 2 is 8. And then don't forget to cube the x as well. And this is -2. Now here I have 4 choose 2. There are 6 ways of doing that. This becomes 4x squared, and this becomes +4 because obviously you're squaring the negative. Now for this one, 4 choose 3. I already knew that was going to be a 4. Now the reason I knew that was because we talked before about the twins. So 4 choose 1 and 4 choose 3. They're opposites of each other, and they give you the same result. So 4 choose 1 or 4 choose 3 gives you the same result. This one's going to be careful, -8. Now 4 choose 4. So if you think about this, 4 choose 4 is going to be the same as the first one, as 4 choose 0. So I'm expecting this to be a 1, and it is. Anything to the power of 0 is 1. Now if I raise 2 to the power of 4, it's 16, and it's +16 because we've an even power and a negative in the question. So again, if you're not sure, just take your time with it. So 16 to the power of 4, then I have 8 by 4 by -2. So be careful, -64x cubed. Then I have 6 by 4 by 4, that's 96x squared. 4 by 2 by 8, by -8 is -64x. And then finally 16. Okay, so I'm going to stop this video and I'll continue it in the next.